Dear friends, hoping that you are all fine with the blessings of Almighty Allah. Right now, we are solving one very important paper, paper 6. Paper 6, variant 1, and the year we have chosen that is October November 2020. And as I'm telling every time, this is a paper which is 1 hour long, means 60 minutes, and it has 40 marks. And it is simply the 20% of the weightage for our syllabus and curve. So let's start. Question number 1. A student determines the density of modeling clay by two methods. Method 1. Figure 1.1 shows one phase of the modeling clay that the student uses. This is sample A. The student measures the depth D of the sample A, and that is mentioned is 3.2 centimeters. So depth of this modeling clay is given. Now diagram is in front of us, and it is drawn actual size, full size. So measure and record the length L and the width W of the sample A of the modeling clay. Figure 1.1 is drawn to actual size. So when we are making use of the ruler and trying to get this answer, we are getting this length equal to, by making use of a ruler, this length comes to be almost 3.1. So 3.1, and unit is already mentioned in centimeters, so no need. But if it's not there, we have to be careful. We have to write the unit. And then we are supposed to measure the width that is from arrowhead till the next other side arrowhead. So that is almost to be 2.7, and it is also measured in centimeters. Now, the examiner wants us to calculate the volume VA of the sample A using the equation VA is equal to length times the width times the depth. Depth means height. You can also say thickness. So we will, all the values are with us, so we will be multiplying them together. So 3.1 times 2.7 times 3.2, and after calculation, we are getting the answer 26.784. We are not going to write this much long number. We can use maximum 3 significant figures. So I'm going to write it, sorry, not 26. Yeah, so we can write it rounded off, and we can write it to be 27.0 centimeter cube. Then, my dear friends, check here. Next part, figure 1.2 shows sample A on the balance. Record the mass MA of the sample A to the nearest gram. Okay, here it is nearest gram. In the fresh papers, they are also asking nearest 0.1 gram. So right now, nearest gram, 50.78 to 0.7, which is greater than 5. So we can just write the next number and dropping the rest of the things. So 51.0 gram. If it was to the nearest 0.1, if it was to nearest 0.1 gram, then my friend answer was going to be 50.8 grams. If it was asked, but right now he's asking about the nearest gram, so answer is 51 grams. And the good thing always about this paper, the formula equation is given, the rule is given. Calculate the density rho A of the sample A of the model in clay using the equation rho A is equal to MA over VA, mass of the clay A and the volume of the clay A. To give you an answer to the suitable number of significant figures for this method and include the unit. Of course, include the unit. So when we are trying to get the answer, that is C61 over 27, and we are getting the answer 1.88, 1.888, and I'm writing the answer, by the way, 1.89. And what about the unit? Mass was in gram, and the volume was in centimeter cube. So unit will be grams per centimeter cube, 2 marks. Now, another method too that is mentioned. So the student records the volume V1 of water in a measuring cylinder. It means the student is now going to choose the displacement method. So he measured the volume of water, that is 150 centimeter cube. He carefully lowers the sample B of the same modeling clay into the measuring cylinder until it is completely covered with water. So it is deep into the water down such that even its surface is dipped underwater. It's placed underwater. Now he records the new reading V2 of the water level in the measuring cylinder, and the new value is 182 centimeter cube. So VB, volume of sample B, using the equation, that is equal to 182 minus 150, and very simple, without use of calculator, that is equal to 32 centimeter cube, and unit is centimeter cube. The student measures the mass of the sample B, and it is equal to 60 grams. Calculate the density rho B of the sample B using the equation rho B is equal to MB over VB. Give your answer to the suitable number of significant figures for this method and include the unit. No worries. So mass is 60 grams over the volume is 32, but that is in centimeter cube. So as we are simplifying this answer, calculating this answer comes to be 1.875. So we can round it off to be 1.88 grams per centimeter cube. Now, a student suggests that the density of the modeling clay is not affected by the mass or the volume of the sample used. Whether whether your results agree with this suggestion, justify your answer by reference to your results. Now see, we will see mass. Here, initially the mass was 51 grams, and the density is 1.89 grams per centimeter cube. And when the mass is almost 10 gram or 9 grams more, again the density is 1.88. Not a big difference. There is a difference of 0.01 grams per centimeter cube. So statement yes. And justification with reference to your results. So either you can write within the limit of experimental accuracy, or you can write 1.88 grams per centimeter cube is almost equal to 1.89 grams per centimeter cube. So yes, you can say now this is within the limit of experimental accuracy. What does it mean? It means if your answer is above 90% or 90% accurate, then it is okay. And we will say that it is yes, within the limit of experimental accuracy, or your percentage error you can calculate between the two numerical values which you are willing to be constant. So if the percentage error or uncertainty is less than 10%, even then yes, and within the limit of experimental accuracy. You can watch this in my other videos, or some more past paper questions I will be uploading on channel. So inshallah, you will be seeing them again in some other papers. So if it is less than 10, more than 10%, like your percentage error is 30%, so it means you are right in the statement no, and outside the limit of experimental accuracy. No need to give any detail within the statement. It is recommended by the examiners that you can write either yes or no according to the situation or the numerical values which you are having. Okay, let's move forward now. The student tick the boxes that describe the correct line of sight for taking the reading of the volume of water in the measuring cylinder. Figure 1.3 shows the curved surface of the water, which is called the meniscus. Which is called what? The meniscus. And we know two things we are always checking, that eyesight should be perpendicular to the scale, 90 degrees, and in line with the bottom of the meniscus. If I'm going to draw it roughly here, So like this. So this will be the line of sight. And C making an angle of 90 degree, and it is with the lower level of meniscus. No need to draw it, but you have to just take it. So in this way, first question of 11 marks we have completed. Let's move forward. So the next question is now cooling of water. So a student investigates the cooling of water under different conditions. So figure 2.1 shows the apparatus she uses. Apparatus, there is a beaker. Of course, there will be water inside, hot water inside, a clamp holding the thermometer vertically such that the bulb of the thermometer is dipped into the water and it's not touching any side of the beaker or the bottom of the beaker. Bench is there, boss is there, stand is there. Okay. Now the thermometer in figure 2.2 here shows the room temperature theta R at the beginning of the experiment. Record theta R. See, it is in degrees Celsius. So first of all, write the unit degree Celsius 2021. So room temperature is 21.0 degrees Celsius. 21. Okay, my dear friends. Next is then the student pours 200 centimeter cube of 200 centimeter cube of hot water into the beaker. She records the temperature theta of the hot water at time t is equal to 0, meaning initial temperature of the hot water. She immediately starts a stop clock. After 180 seconds, she measures the temperature theta shown on the thermometer. The temperature readings are shown in the table C 85 and 69. Complete the time column and the column headings in table 2.1. So column headings and time column. Time columns he started from 0 and finally he measures the temperature at 180 seconds. The time is in seconds, air seconds, and temperature of course in degrees Celsius. So time column is completed and column headings are also completed. Be very careful. It is always asked in exam in paper 6. Calculate the drop in temperature, fall in temperature, delta theta 1 between T is equal to 0 and T is equal to 180 degrees Celsius. So very simple. We can write 85 minus 69, and that is equal to 16. And only writing 16 will give us 0 marks, 16.0 even if you want to write, but don't forget to write degrees Celsius. Calculate the average rate of cooling. Rate of cooling, it means time will be involved and time will be in denominator. So rate of cooling means, for understanding, you can think this is the speed of cooling of the water using the equation R1 is equal to delta theta 1 over delta T, where delta T is also given 180 seconds, include the unit of course, we will be including. So 16 over 180, as we are simplifying it, we are getting the answer 0.0888. So we can write simply 0.089 degrees Celsius per second. Why? Because this fall in temperature is in degrees Celsius and time is in seconds. So degrees Celsius per second. That is what? That is the unit for this rate of cooling. The student empties the beaker. She pours now 150 centimeter cube of hot water into the beaker. See, there is a difference. Before it was 200 centimeter cube. Right now, 150 centimeter cube of hot water. She adds 50 centimeter cube of cold water to the beaker. Now, total volume is again 200 centimeter cube, but 150 is hot water, 150 centimeter cube, and 50 centimeter cube is the cold water. She repeats the timing and the temperature recordings procedure described in B. The temperature readings are shown in the table. So again, complete the column headings, time column and column headings in 2.2. So time is in seconds, temperature in degrees Celsius. Starting temperature is starting time is 0 seconds, and final time is 180 seconds. It means after 3 minutes. Now again, calculate the drop in temperature delta theta 2 between T is equal to 0 and T is equal to 180 seconds. So my dear friends, 69 minus 57, answer is 12. So right now, temperature fall is 12 degrees Celsius. Now, same rate of cooling R2. Calculate the average rate of cooling R2 of the water using the equation and include the unit, and delta T is again 180 seconds. So it means answer is 12 seconds over 180 seconds, as we are simplifying. So 0.0666. So we can write 0.067 degrees Celsius per second. Now, my dear friends, a student suggests that the average rate of cooling R of water depends on the difference D between the temperature of the water at T is equal to 0 and room temperature, which was 21. Room temperature. Very first mark on this experiment was 1 mark for recording the room temperature, which is 21. So initial temperature of hot water or initial temperature of the mixture and the room temperature difference, we have to calculate it. Calculate the difference D1 using the equation in table 2.1 and your answer to A. My dear friends, here 85 was the starting temperature and 21 was the room temperature. So difference is 64. So here we are going to write 64.0 and don't forget to write degrees Celsius. Very important. So answer A. See, in case of A, table 2.1, starting temperature is 85. So that's why 85 minus 21. Now I'm going to do 69 minus 21 for D2. So calculate the difference D2 using the equation in table 2.1, readings in table 2, and your answer to A. So my dear friend, now it will be 69 minus 21, 48. And don't forget to write degrees Celsius with 48. Write a conclusion about the relationship between R and D. Justify your answer by reference to the results. No problem at all. So we can say that the rate of cooling R is proportional to, we can write directly proportional to also, but proportional will work and we will save time also. So it's proportional to difference of temperature. Difference of temperature. What is that? That is D. Difference of temperature, D. So now justification, they said with reference to the results. So results we have already, like for D1 when it is 64. So you know rate of cooling was 0.089. And then when the difference of temperature is less, like that is from 69, so rate of cooling is 0.067. So it means, my dear friends, what can I write? Here we can write for D1, which is 64, rate of cooling R1, roughly I'm writing 0.089, but don't forget to write the unit degrees Celsius per second. And also here, write the unit degrees Celsius like this. And for T2, which is 48 degrees Celsius, R2 is the rate of cooling, which is 0.067 degrees Celsius per second. And we can see when the difference of temperature is higher between the temperature and the initial temperature of hot water, the rate of cooling is higher, and vice versa. Vice versa means the reverse of it. When the difference of temperature is smaller, the rate of cooling is also smaller. And difference of temperature between what? In this case, we can say difference of temperature between the initial temperature of hot water and the room temperature. Next is explain why the thermometer should be read at right angles. So very simple answer is avoid parallax error. This is the recall memory, simple formula question, normal question to avoid parallax error. Now, explain why mixture of hot and cold water should be stirred before taking the temperature reading at the start of the experiment in C. If you are not stirring it, so it will take longer time for the water to mix up and the temperature to be uniform throughout the liquid. So when you are stirring continuously, so it will keep the temperature throughout the liquid same or constant. So simply we can say keep the temperature of mixture of water constant throughout the liquid. Throughout the liquid. Okay, my dear friends, I'm sure this will be clear. Let's move forward to the next part now. Yes, that is about the lenses now. And this is the question of lenses with a graph. A student investigates the magnification of the image produced by a lens. And again, magnification is one of the physical quantities with us in the syllabus, which has no unit, as it is a ratio between same quantities. Ratio between same quantities. Figure 3.1 shows the apparatus used. Figure 3.1 shows the apparatus used. Now, what we are going to do and see first of all here, always this is the pattern. Extreme right side, there will be a screen which is kept vertical with the help of a support like bench. And screen is the position or the place where the image is produced if the image is real. V is the distance from the image to the center of the lens. See, the distances are taken from the center of the lens. And U is the distance from the center of the lens to the illuminated object. Object is there, which is illuminated with the help of some light. So extreme right is the image screen. Extreme left is the object. And in between, there is a lens. And another thing, check the center of the object, center of the lens, and the center of the screen. They are almost same level from the bench, from the ground, same height from the bench, from the ground. This is a very good technique to get some sort of reliable image on the screen. Well focused, reliable image. Figure 3.2 shows a triangle hole in a card that forms the illuminated object. Figure 3.2 is drawn actual size. So on figure 3.2, measure and record the height HO of the object. And when we are measuring it, 1.5, and see the distances are given in centimeters. So this is also centimeter. We have to measure from here till here. Now, the student places the lens a distance U 20 centimeter from the object. So this was taken initially equal to 20 centimeters. He moves the screen slowly until a clearly focused image is formed on the screen. He measured the distance B between the center of the lens and the screen. Then he is repeating the same procedure using the values of U equal to 25, 30, 35, and 40. The readings are shown in the table. So all the readings are there in the table. And what we are supposed to do now, units are there, everything calculate and record in table 3.1. The magnification M for each value of U, use the equation M is equal to V over U, V over U. So 70.9 over 20, we are getting 3.54, and here check m is equal to 70.9 centimeters over u is 20 centimeter cancelled, and we are roughly getting 3.54 without a unit. So if magnification is not having a unit, of course it's not having a unit. So it is because it is a ratio. Only seeing ratio is not enough. It is a ratio between two same quantities. Then 41.5 over 25, and we are getting numerically equal to 1.66. Then 32.5 divided by 30, it is equal to 1.08. See, I'm consistent with the decimal places. Even I was in a position to write it 1.1, but that will be written correctly in a way that 1.10. So I kept it like this, 1.08. And then, my dear friends, 28.1 divided by 35, now it will go less than 1, and that is almost 0.80. And the last number, 25.6 over 40, to get m magnification, which is v over u, answer is 0.64. So all the data which I have written, it is consistent for two decimal places. Now, plot a graph of u in centimeters on y-axis. Don't forget to label in centimeters on y-axis against m magnification on x-axis. So, my dear friends, what we can do here, first of all, better that label the axis. It is already there. Just draw a line, label it this way, and also draw the line here. And magnification again, it's not having any unit. Like this, roughly I have done. So now we have to choose a scale. When we have written it like this, so our first mark is score. Start the y-axis at u equal to 20. So we are forced to start this one equal to 20.6. Then we have values for u from 20 to 40. So see how I will be choosing these numerical values. So I'm going to choose them. See 20. This is 25.0. This is then 30.0. This is then 30. Now better it should be here. So this is 30.0. This is, oh no, no, here wrong, not 30. This is 35.0, and here it is 40.0. So up to 40 we are supposed to go. And why I have done it like this? So that more our data is scattered, or it is covering more than half of the grid on y-axis. And again, we need, of course, to label them. So one small square is equal to, say, 25 minus 20 over 10. So it means each small box is equal to 0.5 centimeters. Now the value of m, they are from 0.64 to 3.54. It means 0.5 to 4 we can use. 0.5 to 4 we can use. Like in general, what we are, how we are getting the number of boxes. See, we can use 3.5 4 minus 0.64, that is equal to 2.9. And how many squares we are having? See, 1, 2, 3, 4, 5, 6, 7, 8. So my dear friend, 2.9 divided by 8, answer comes to 0.365. That's not making any sense. So just add something to it, like we can make each big square equal to 0.5. So that's what here, starting with 0. So 0.50, then 1.0, here 1.50, here 2.0, this one will be 2.50, then here it will be 3.0, and this one will be 3.5. And you can check here, my dear friend, we have scored the second mark because our data is scattered on more than half of the grid. So we are going with one decimal place, so better to write like this. Okay. So now 2 marks we have scored. And what about the one big square here? See, if one small square, sorry, here also one small square is equal to, you can write again 0.5 minus 0 divided by 10. So each small square is equal to 0.05. 0.05. So two small boxes on x-axis equal to 0.1. And make this M very clear. It should be very much visible to the examiner. So don't put it in some place which is too much congested. Okay. Now let's start labeling the points. See, we have the first value. When U is 20, M is 3.54. U is 20, M is U and M. Wait a minute. U is 20, M is 3.54. U is 20. See, U is 20 here. Now I will be using another color like this blue. U is 20, 3.54. So see, this is 3.5. 3.54. See, this is 3.55. Next value. So 3.54 is exact somewhere here. You can say just starting from here and see our value is after 3.5. So I did not notice at that moment. So you should also write it as 4.0. Anyhow, our first box is like this. Then the second numerical value is, my dear friends. Now, second numerical value is 25, 1.66. 25, see 1.5 here. So 25, this is 1.5, and we need 1.66. So 1.5, two boxes 1.6. This is 1.65, almost here. This is the second number. Our second point located. Then the third value is 30 and 1.08. 30 and 1.08. See, this is 1. This is 1.1. Two boxes, so just ahead of it, like this. And then, my dear friends, the next value is 35.80. 35, see, this is 1, so two boxes here. This is 0.9 and this is 0.8. So here, and then, sorry, we can just make it more precise by this way. Okay, and then the last point is at 40, it is 0.64. 40, see, this is 0.5, this is 0.6, almost 3 squares like this. So now these are the points. When we have located these points, my dear friends, we have scored the third mark. Now the line of best fit here, but it will be the curve of best fit. Curve of best fit. So I'm going to draw it for the fourth mark. No need to use the scales to draw this, and try to go freehand curve this way. This way. And then, my dear friends, something like this. This way. So that is the curve of freehand curve, and that will give you the fourth mark. So for the graph question, first mark for the labeling according to the given circumstances. Then scatter the data on the grid such that more than half of the grid is covered with data on x-axis and y-axis. And then, my dear friend, the last third mark is for locating the positions of data points in the form of crosses, plus or dot in a circle. We are using the cross. And then the last mark for the graph or the line of best fit or the three-hand curve, like in this case. Use your graph to determine the value of the object distance U1 when the magnification is 1. So magnification is 1 and show clearly on the graph how you obtain the necessary information. Just use your ruler, go this way, till it touches the graph over here, then come this side, see 3, this is 31, and this value is basically 31.5. 31.5. So U1 is equal to how much? That is, my dear friends, 31.5 centimeters. Don't do anything in your mind, in the perception in your mind about a particular topic. No. In paper 6, wholly, solely, completely, you have to follow the instructions by the examiner. So the focal length F of the equation, F is equal to U1 over 2. So it means 31.5 divided by 2, and we will get 31.5 divided by 2, it is 15.75. So we can write simply 15.8 centimeters. 15.8 centimeters will be the answer. Centimeter is already written. So then, very common question, formula question. State 2 precautions that you would take in this experiment in order to obtain accurate readings. So, very common, perform the experiment, because it is the experiment with light and the image is made to perform the experiment in dark room or in shaded area. Perform the experiment in dark room, or you can say shaded area. I can give you an example. Let's suppose you are in your university and some very famous scientist or the speaker or the professor is there to address you people in the auditorium or in the conference hall. So the speaker will be on the stage and the dials will be there and there will be very bright light on him. And in general, the lights in the auditorium or the sitting area where the listeners or the students and the other teachers are sitting, there will be either very dim light or completely darkness so that you can focus more and concentrate on the speaker. So some sort of the concept, same concept here, because this is a light experiment. So we can perform this experiment in shaded area or dark room to get well clear focus image. And second thing, you can say that measure all the distances from the center of the lens, or as I told you in the beginning, that ensure that center of the object, lens and screen are at the same height from the bench. So we can also say that ensure that center of object, center of lens, and center of screen are at same height from the bench or table, whatever. So question number 3 is solved. Now, a student investigates the resistance of different wires. Student investigates the resistance of different wires. Plan an experiment to investigate the resistance of wires made from different metals. So resistance and different metals. Different metals is independent variable. And resistance, this is dependent. Dependent variable. And very important, because independent variable is helping us a lot to Right, 2 3 points. Even in the table, it is there. Independent variable is in the beginning, first column heading, and the dependent variable is the last column heading. And when we are repeating the experiment for improvement, we are also uh, repeating by changing the independent variable numerical value or its like different metals by metals, different metals. Resistance is calculated by using R is equal to V over I. The following apparatus is available. Ammeter, of course, to measure current, voltmeter to measure voltage, power supply to provide us with the potential difference, meter rule to measure the length of the wires, a selection of wires made from different metals. You can also use, what? You can also use other apparatus and materials that are usually available in a school laboratory in your plan. We should a list of the suitable metals for the wires you would investigate, draw a diagram of the suitable electrical circuit using standard symbols, explain briefly how to carry out the investigation, state the key variables to be kept constant, and then draw a table or tables with column headings to show how to display your readings. You are not required to enter any reading in the table. Please, the students are habitual, even the mock exams which we are conducting in our schools. So if the students are trying to write their numerical values in one column or two columns, you are not performing the experiment. So how you are in a position to write in external exams when you are sitting in the examination hall, you are writing, you are describing the experiment, you are not conducting the experiment. So how can you put the numerical values into the table columns? So never do this mistake. Now let's start. First of all, we need to let's start with the circuit diagram, I think. So we will hit all the points. Okay, write a list of the suitable metals for the wires you will investigate. So my dear friends, let's start with that. You can say, I am investigating the resistance of metals, namely, which are easily available: copper. At least three names you should give: copper, aluminium, iron, etc. That's okay. Three metals are more than enough. Fine. Then draw a circuit diagram of suitable electrical circuit. Now see, always start, and here they said power supply. So power supply symbol is, now I will be writing the circuit diagram to investigate resistance, the circuit diagram to investigate the resistance of different metals is as shown below. Resistance of different metals is shown below. See, power supply. To start with power supply, two small circles like this. Don't forget to enter a switch. Then ammeter is always in series. Then, my dear friends, leaves two terminals where you can connect the wires. Let's suppose this is C, this is D. And voltmeter is always across the component where we need to measure the potential difference, not small v, it should be capital V. Even you can include here a variable resistor, even they did not mention, for controlling the current you can use. So this is the complete circuit diagram. But before that, my dear friends, I can give like this. Now see, better to label this diagram. Like this is power supply. And we know this is a switch, which is right now open. This is an ammeter to measure the current and always connected in series. This is, you can say, one of the metal wire, one of the given metal wires. This is voltmeter. And this one is variable resistor by the way to control the current. Now, what is the next point? Next point is explain briefly how to carry out the investigation. You can say connect one of the given wires, connect one of the given wires, connect one of the given wires between points C and B. Turn on the switch and measure current I and current I in the wire and PD. I'm writing the abbreviation for potential difference. Potential difference will be across the wire. Then find the resistance of wire by R is equal to V over I. Now, this is the brief explanation of the procedure. Now, it is always there that repeat the same method. Now, here, independent variable is important. Repeat the same method. What was the independent variable? Different metal wires. Repeat the same method. Independent variable was different metal wires. Repeat the same method by connecting different metal wires between terminals E and B. Next point is state the key variables to keep constant. Here, see, we are just considering the nature of the material, nature of the metal wire, material of the metal wire. So what we are going to keep constant, my dear friend, length and area of cross section of wires is kept constant. Then, what is the last point? Of course, that is the table. So we are supposed to draw the table also here with column headings. So first of all, again, in the table, metal wire, material of the metal. So independent variable in the beginning. Independent variable will be in the beginning. So we will say material of the wire per column. Then voltage we measure V over V, both capital. Then current in amperes and the dependent variable in the end, which is resistance in ohms. So like this, we can score all the marks for this experiment. And if you want to write, you can write one precaution that use lower value of current to reduce the heating effect of current. Because if the temperature will become very high, so the resistance of the metal, even for the same metal, it will be getting higher. So these are the key points for this paper, and I'm hopeful that you have understood it and it will be beneficial for you. If you are satisfied and you like these explanation. So please follow the channel, like it, and subscribe by yourself and share it with your friends and family. Stay blessed. Take care. Bye.